Okay, these are our lesson 4.4 notes about parallel and perpendicular lines. On your own, you did the first 2 pages of this packet, and I will go over them briefly at the end of these notes, but we need to get into the 3rd page, which is the guided practice. So if you look at page 3 of your notes, at the top where it says parallel lines, and you see the 2 little lines that are parallel, have the blank blank and it rate of change, so they have the same is what you should have there. So have the same. So parallel lines have the same slope. That's what we learned on the first exploration on the first pages of this packet. And then perpendicular lines have slopes that are, and we can call them opposite. That way we know that they have different signs. And I like to say the word opposite, and they're multiplicative inverses. So opposite inverses. And it's really multiplicative inverses, opposite multiplicative inverses. Or the other word we use for that is reciprocals. My handwriting's not great today. Okay, so example 1, it says write an equation in slope-intercept form. So slope-intercept form, we should know by now, is y equals mx plus b, where m stands for the slope and b is your y-intercept. And for the line that passes through the given point and it's parallel to the graph of each equation. Well, that means I'm going to have the same slope. So I look at the line here and it needs to be passing through here. So basically, we're looking for a line that's going to be parallel and comes down something like this. Okay? Just to give you a visual of what we're looking for. It's not a perfectly parallel line, obviously, but something like that. But it has to go through this point and it has to have the same slope. So my parallel slope, that's an M, is -1/2. Now I have a point and a slope to create the equation of the line. We've done this several times. Cross that out. Okay, so we get y minus 7 equals -1/2 times x minus, or x, excuse me, plus 8. Then we multiply through to our binomial, and we get y minus 7 equals -1/2 x minus 4. And then we add 7 because I want to get y by itself. And I get y equals -1/2 x plus 3. And I want to double check. So my slope should be the same. That's what lets me know it's parallel. And then my y-intercept should really be different because they're parallel, they're away from each other. So that meets both qualifications, so I know I'm good. On B, I'm not given a picture of the line, but I'm given similar information. I'm giving a line and then a point. The only thing I have to do here is put it in slope-intercept form so I know the slope. So I'm going to subtract 3x from both sides. And I get y equals -3x plus 12. And my slope then is -3, so my parallel slope equals -3. And then I have a point. So I have a point and a slope. And I'll change my color so you can see this a little better. So this was the original equation that I put in slope-intercept form. Now I need to use this point and this slope. So I'm going to do it over here. So I get y minus 6 equals, my thing here, -3 times the quantity x plus 1. And it's the same steps from here, so I'm going to multiply through with my slope. So I get y minus 6 equals -3x minus 3. And then we're going to add 6 to both sides. So I get y equals -3x, it's a negative, plus 3. And again, same slope here. I see -3, -3, and then I have different y-intercepts. So that's my answer. So you now have two examples to use when you have to do your U-try. You have an example right next to it, okay? Now we're going to go into perpendicular lines. So it says write an equation of a slope-intercept form again for the line that passes through the given point that is perpendicular to the graph. So the only thing different here is that my slope, I have to do something to it. It's not the same slope. So perpendicular slope here, remember it's the opposite reciprocal. So I'm going to flip this so then it becomes 4 over 1 and it no longer will be negative. So it's a positive 4 over 1. Now I have a point, I have a slope, and I do the same thing I did before. So y minus 3 equals 4, and I'm just going to put that as 4 for right now. We know that that's 4 over 1 times the quantity x plus 2. I distribute my 4, I get y minus 3 equals 4x plus 8. Then we add 3, and I get y equals 4x plus 11. That's a 4. Make sure that you know that that's a 4. So y equals 4x plus 11. And in this case, my check, or what I can do to make sure I did this correctly, remember when we multiply the slopes of perpendicular lines, they should multiply to -1. So -1/4 times 4 equals -1. So I'm good. Like that is perpendicular. It doesn't matter about the y-intercepts. We just need to look at those slopes because somewhere they're crossing and having a perfect 90-degree angle to each other. On B, it's kind of like the B up here. We actually have to solve for y first to get our slope. So I get -x, subtract x from both sides, and I get 3y equals -x plus 6. Then we divide everything by 3 to get y by itself. And so we get y equals -1/3 x plus 2. And so my slope here is -1/3, so my perpendicular slope is going to be, sorry about that, so perpendicular slope here would be a positive 3 over 1, so positive 3. And I'm going to use this information along with this point to make my perpendicular line. Go back to a different color. So I'm going to get y plus 6, because it's minus a -6, equals 3 times the quantity x plus 1. And I distribute my 3, so I get y plus 6 equals 3x plus 3. Subtract 6 from both sides, and we get y equals 3x minus 3. And so again, I'm looking at my slope. So I have 3 here, -1/3. -1/3 times 3 gives me -1. So I know those are perpendicular slopes. Now let's look at example 3. And on example 3, I do want you to change C because it was printed off incorrectly. This should have been -3, 1. And it says on a radar screen, a plane located at A, -2, 4, is flying towards B, 4, 3, and another plane is located at point C, -3, 1, and is flying towards point D, 3, 0. It says, are the plane's paths perpendicular? Explain. One way you could do this is to, find the slope and put it in a linear equation and then graph your two linear equations, and it could be pretty obvious. The other is, the only thing I really need to know when I'm looking for something perpendicular is if their slopes are opposite reciprocals. So you're going to find the slope from A to B, and you're going to find the slope from C to D, and then you're going to compare the slopes. If they are opposite reciprocals, you can explain that and say, well, that's what perpendicular lines have. If they are not, then you can explain that and say, hey, they didn't give me opposite reciprocals, so they are not perpendicular. So either way, you have to compare the two slopes of the pathways of the planes. So example 4 says determine whether the following equations are parallel or perpendicular, and it could be neither too, just so you know. But they don't have to be either or, so don't beat your head against the wall if you're not getting any that are perpendicular or parallel. These two are already solved for y, which it's pretty easy to see the slope. This one is not, so you're going to have to solve for y to get the slope. Then you compare them all. If you find ones that are opposite reciprocals, you know those two lines would be perpendicular. If you see two that have the same slope, then you know that they will be parallel. Okay, very quickly, I want to go back over the first 2 pages for those of you that have not gone through that yet. If you'll see, the chart is kind of filled out for you. You could have picked any 2 points along these lines, so I did not fill out that one, but you should have gotten these as your y-intercepts, these as your slopes. Then we put it in y equals mx plus b. Based on the information, you should have learned that the slopes are the same. What do you notice about the y-intercepts? They must be different, or you're talking about the same line. If I have the same slope and same y-intercept, that is the same line. That is not parallel lines. Those are the same lines, okay? So we need to make sure that we're looking at that accurately. Then number 3, Marcy says that the lines y equals 1/2 x plus 5 and 2x minus 4 equals negative 10 are parallel. Do you agree or disagree? And all it's asking you for is if they are the same or not the same. And you should have agreed because the slopes are the same and the y-intercepts are different, and that's basically what that says down here that's off of our screen, but that is what it is. On the next one, you should have gotten these as your y-intercepts. Here are your slopes. If you notice, every time we multiply the slopes of the lines that were perpendicular, you should have gotten -1. And then they're opposite reciprocals. And Jordan says that these two are perpendicular. Do you agree or disagree? You should have disagreed because 2 and -2 are opposites, but they are not inverses. You have to have both. They have to be opposites and inverses. And then for the last one, determine the equation of a line that is perpendicular to y equals 3. What we have to remember is y equals 3 is a horizontal line with a slope of 0. If you think about it, that we always want to make sense of what questions are asking us. A perpendicular line would look like this, right? Think about your x and y axes. So it should go up and down. Well, what kind of line has an undefined slope, which that's that kind of line? That's an x equals, and you could have picked any value. So x equals 1, x equals 243, x equals 0. Any x equals line will be perpendicular to a y equals line. All right, that's the end of our notes.